Good morning. First of all, let me thank you all for coming here today. I'm Professor Paola Gallo from University of Florence, and the subject of this presentation is the Building Performance Simulation Training for Design Optimization, focused on teaching experience developed together my colleague Rosa Romano and Alessandra Donato in the frame of master school named Habitat. The Habitat Master course, born since 2003 in accordance with EU directives, as responsive to the high interest expressed both in the public administrations by companies and businesses in the wise management of environmental resources and planning sustainable built land. The master teaching method plans to provide to the students an effective method to approach the sustainable architectural design issue using energy simulation tools to predict, anticipate, and optimize the results through the overall design process at different design scale levels as follows. At micro scale, follow the last EU directive concerning the certification of buildings and the monitoring of their consumption introduced a new reality demands for an increase of the number of professionals with specialized technical education in the areas. So this has justified the creation of new specialization area in the master course program. At medium scale, this area is finalized to build competencies for design and analyzing building and urban scale system, both under our perspective of space organizations at the crossroad of criteria related to the sustainable use of natural resources, functionality, and fruition, and under a perspective of building as complex system, addressing conception and operation in a context of efficiency as well as human comfort and health. And final at micro scale. In this area, lessons are offered to allow students topics related with energy and environmental economics energy markets in different cases of organization and regulation, efficient use of energy, and overcoming market barriers, organization of system for sustainability. The energy efficiency program of Habitat Master course includes studies on the building technologies, resources, materials, system design, management, industry structure, and policies in an integrated package. In detail, the master course Habitat is divided in 4 training modules, structured in order to guarantee a basic preparation on the specific theoretical aspects concerning the themes of bioecological architecture and innovative technologies for environment. These 4 training modules are dedicated to the following specific topics. The modules 1, transforming the existing from the smart city to the sustainable building. In this module, the students are involved in practical experience focused on the outdoor comfort analysis of a specific urban spaces using specific software for microclimatic simulation. The module 2, building environmental design from the smart materials to the adaptive envelopes, aims to provide the basic knowledge necessary for a sustainable design with the reference to the broader European regulatory framework on the energy system. Furthermore, the most innovative technology to improve the energy performance of the building and to achieve the target ZEB are presented. At the end of this module, the student developed a design concept of a sustainable building, analyzing in the preliminary stage an environmental impact of the proposal. The Module 3, the analysis energy performance of the building plans and evaluation of internal overall comfort, is focused on the analysis of the building plant energy performance and the evaluation of internal overall comfort. A special focus is dedicated on the topic of energy audit, involving the students in a practical activity concerning the analysis of a public building located in Florence, and together with the development of a retrofitting proposal. The Module 4 aims to increase the student knowledge of simulation tools, to develop building energy models, assessing simultaneously the geometrical formal characteristics of their architectural work and energy environmental performances, together with issues linked to cost and building management from the implementation phase to the use phase. The energy efficient buildings simulation increasingly requires the use of parametric analysis tool, so it's evident how the PMs are useful to evaluate alternative design solutions, contributing to decision making at the early stage design process and improving the whole building construction quality. For these reasons, the implementation of BIM methods with habitat mass scores was developed since 2015 to introduce students to intermediate and advanced dynamic simulation concept with reference to some key issues in the sustainable approach, both in urban planning and building design. In detail, the Module 4 is focused on the knowledge of applicative methods and dynamic simulation tools to achieve nearly zero energy building standards in the project, and master students are strongly encouraged to use building performance analysis tools applied on the field of advanced envelope system, in particular during their experience master thesis. In this slide, you can see three master theses related to the topic of building envelope, deep renovation, urban design. These three final student work as example demonstrate how the BIM and BPS tools lead the students to rethink their approach to the project on the basis to the necessary environmental reflection, assessing architectural, compositional, formal and technological choices. In conclusion, the quality of the results validated the choice of teaching methods, which has contributed to increase the cognitive maturity of the young architects linked to the technological and environmental options made at the design scale. A choice that requires an increasing degree of specialization and care at the scale of technological detail for the integrated project, but especially of responsibility toward professional assessments that can have irreversible effects on our future and on that of following generations. Furthermore, it's clear how even the sector of the sustainable building design is required to evolve from collective intelligence into connective intelligence made up of physical and virtual network in which researchers and designers become the barriers of knowledge linked to operational and decision-making process involving horizontal skills. The analysis of innovative technological solutions for ZEB require the use of multiple BPS tools that often produce interoperable outputs in the context of BIM environments. Therefore, it's essential that designers learn to define simulation strategies from the perspective of the design objectives more than the use of single analysis tools. Thank you for attention.